All right, let's dive into some internal link analysis. I know I have mentioned this in several of my talks and sort of realizing that my notebook doesn't do the best job explaining how to do this and where to modify things. So I thought a walkthrough video would be really helpful, and major shout out to Lily Grozeva. I hope I'm saying that right. It's a beautiful last name. For the little nudge on this on Twitter. I really appreciate you. And yeah, hopefully this video will give you everything you need to be able to do this yourself for clients and different websites. So thank you so much, Lily. I appreciate you. All right, let's dive into this. So I'm gonna make sure this code is as big as possible for you to see. And so what I would suggest, I'll send you the link to this, and you're just gonna come in here and save a copy in your drive. And you can name it whatever you want. It doesn't have to be quick and dirty internal link analysis. I kind of named it that because it's rough. This is my own chaotic brain. Uh, this notebook can be improved, and we're going to do that right now. So first thing you're going to do is you're going to come over here and you're going to make sure that you're connected to a hosted runtime. So I believe I already am. If I'm not, and because I tried making, I'm just actually going to restart this. So I had tried to shoot a video before this that did not go well. Ran into a couple things I forgot about. So you're gonna restart your runtime if you ever need to do that. If you're rerunning data or pulling in a different client's website, you would do that same thing. So that green check mark looks like I am all good to go. And so all you're gonna do, well, first off, I go to Screaming Frog and I crawl the site that I want to analyze the internal links of. And I select all the URLs, and then I go down to that bottom area of Screaming Frog and download all of the in links, right? So it's collecting all the information of every single crawled page. What are the to and from links of that page? Um, and then once you get down here to the code, don't let any of this intimidate you, I promise. It's super simple. You click into this cell and you just hit Shift Return. And all that's doing is it's collecting those libraries for us to use further down in the notebook. We're going to, again, Shift Return this next cell, and you are going to grab your inlinks file. Right, open. Now this part's super important. So you'll see it's 100% done. This is where people have gotten confused with this notebook. So what you need to do is exactly how it's uploaded here. And so actually, I'm going to have to add this one thing. So I am going to copy this exactly how it's been uploaded. I'm going to come down here. I need to modify this because this is a new upload. I'm going to paste it in here, and I'm going to run this cell to name the data frame to collect this data. Does that make sense? I am assigning the data to a name called DF, data frame, which is kind of the standard notation for these things. So I'm going to run that cell. Looks like it works. And again, as I'm doing this, I am just shift returning even through these text cells that you see here. So my hands kind of stay on my keyboard. So I'm going to do df.head just to make sure that it pulled in the data okay. Fingers crossed. Yes. And so this shows the first 5 rows of data, including the header. Similarly, you can take a look at the tail. This will be the last 5 rows, including the header. Looks good. And now we can start to do some really fun things. So you can start to evaluate counts of things. And so let me just explain what this is doing so you can kind of wrap your head around it and use it for other things if you need to. So here we're calling the data frame, and then if you look up here, we're calling this to column, and we are collecting all of this column's data as value counts. So how many times is this Launchpad Bemidji WP content upload, blah, blah, blah? How many times is it linked to, right? That's what it's doing. So we're going to go ahead and run this, and we see the most linked to URLs and the least linked to URLs. And sometimes you immediately see outliers. At a glance here, the images, I don't think we would want to link to that a lot for this particular site, so I'm not going to worry about it. But you can see that kind of these more primary pages are linked to quite frequently. This GIF is interesting. I don't know what that is. But this starts to give you an idea of, are there any important orphan pages that you should be aware of? Similarly, you can evaluate the count of the anchor text. So what's the most used anchor text for this site? Is there a good variety of keywords within the space? You name it. So this is super helpful to kind of get an idea of, is there anything you can better prioritize in terms of your current goals for ranking and for content, etc. You can very quickly find all the links to a very specific page. So let's say this meetup page is outranking your updated meetup page for some reason, and you want to kind of reallocate internal links properly, again, both for users and for search engines. You would just run this column or this code cell, and boom, we immediately see all of the links going to that specific page. And you can see the anchor text and all that good stuff. And again, you'll discover lots of these are navigational links, but this helps kind of clarify where you could potentially reroute internal links more properly. And just it's me learning about pandas on a different tab. Oh, you got to be learning. I'm not by any means a pro at this stuff. It's hilarious. I'm doing the best I can. But okay, so you can find all links to X page, yada yada yada. Lily's like, what have I gotten myself into? Why did I ask? I'm just kidding. Okay, so this kind of keeps going into Brittany's chaotic wormhole of analysis, where I thought it was a good idea to bring in keywords and join them with internal links to find cannibalization with URLs and with obviously like with keywords. So if you've got multiple URLs ranking for the same keyword, you should be aware of that and which one should be outperforming which. That's super helpful. But Lily, where I think you're coming and where I think most people are coming from, we're just going to delete these, is you're simply trying to analyze these things. And so what I would suggest you doing is adding what is called, it's a filterable table. So I'm just going to add this. I hope this works. Load collab.data table. And then I'm going to just print df. Please work. So this kind of surfaces, yes, this surfaces a SQL-like filterable table that's super, super powerful. So instead of running all of those code cells to discover, what something's to and from and anchor text and blah, 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 I would suggest simply kind of sticking it with this table. So what you do is you go over here to the filter, and boom, you can start to do all sorts of really cool analysis. So show me all internal links that contain, let's see, should I say events? I don't even know. Oh, there we go. Okay, these are all the internal links that contain event. Similarly, you could say, show me all the links to events page. And then boom, we get an instant view of all of the links that go to this page. And this is so cool. You can even drop this down to 50, so it's all on one page if that's applicable to you. But this is just a really nice and easy way to kind of get an idea of what's going on with internal links, right? And you can also explore by alt text if that's applicable, follow links, true, false here. I actually don't think this website has any no follows. Let's try false. Yeah. Link attributes aren't applicable either, but yeah, you can do all sorts of really, really powerful stuff here. So you can look at the redirects. This is sort of where I think it will be powerful in terms of depending on what you're trying to do internal link wise to better optimize your efforts. I feel like I'm just blabbing now, but you get it. Super helpful. And then if you ever want to get out of this, so let's say you run this filterable table and then you want to create a new filtered view of some sort, right? So let's say you want to do something like, let's just do df.head. It's going to still have that filtered view on it, which is sort of weird. So if you want to get rid of it, this took me a while to figure out, but you can I'm just going to explain this. So disable table, you just do kind of the reverse of the above. So unload ext google.colab.data table, and then if we do another, I should have just added that to the above, df. Now we're back to square one. So I hope that helps. Again, this is a very rough analysis. I could see where different visualizations could be incorporated and super, super helpful in terms of what's the distribution of internal links. What does that visually look like? How can we better understand that? And those are things that I will continue to work on incorporating and making more helpful. And those will be live on Data Sci 101. But Lily, I hope this kind of helps you and other people interested in internal link analysis. Man, this stuff is a struggle. If I can help any of you kind of access this better and more easier than my trudging through all this stuff, I'll be happy. So hope this helps. Thank you so much for the nudge. And yeah, I look forward to hearing everyone's thoughts and feedback on how we can make this better. Bye.